First, RMS stands for what? Root mean square. RMS value. Question number 1 objective. It is based on, yes, 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 heating effect. For current and voltages, it is based on heating effect of current. Same heat produced. Means what? First, we will take up first part, half wave. RMS value for half sine wave. So you have a sine wave I t flowing for how much time? Half time. Through what? A resistance. So the definition is, it is that DC current IRMS value is that DC current when flowing in the resistance or a circuit gives you what? Gives same heat. So this is the actual case. A sine wave current flows in a resistance, so there will be heat produced. DC current, single value for which the heating effect comes out to be same is known as RMS value. So for the sake of convenience, I will write the right part first. Heat produced due to RMS is, in this case, yes, how much is the heat produced? I square R power into time. So heat produced is I square RMS, resistance is R, I square R is power into time. What is the heat produced in this case? Instantaneous current is how much? I. If the current at this moment is I, heat produced is I square R in small time dt. It cannot be written as an area in this graph here. If any of the cases, if you have to write this as an area, then I square, you will have to plot a I square into dt. This is what I square. I square into dt, in case you want to plot on a graph, please don't plot for IT. You will have to draw it for I square in case you want to represent. There is no need to represent this. So it is I square R dt is what? Small amount of heat. In how much time? Dt. But we want total sum of all. Integration means infinite summations. For how much time? 0 to T by 2. So the concept is heat. Heat produced by DC current, RMS value, same as that of given by this AC variation. Time with you is 2 minutes and try now. R is cancelled, try. 2 minutes to note and try. Yes, help. R cancelled. I is equal to what? Yes, again it is a sine wave. This is the maximum value. I is equal to I max sine omega t. It is equal to what? Im sine omega t square dt. It is equal to, yes, limits we will put at the end. Im square sine square omega t dt. Sine square theta is equal to what? Yes, sine square theta is equal to 1 minus cos 2 theta by 2. Correct? So sine square theta is equal to 1 minus cos 2 omega t divided by 2 now integration dt. On the left side what you get is I RMS square t by 2. 2 minutes to try. 2 minutes to try for integration. Integration of 1, yes. 2 you can take it out. Integration of 1 is what? T minus integration of cos 2 omega t is sine 2 omega t by 2 omega. Limits 0 to t by 2. On the left hand side, RMS square t by 2. Yes, Im square by 2. Limits this value, upper limit t by 2, lower limit 0. I am talking about only t, upper and lower value of t. What about this? Yes, when you put upper value of t, 2 omega is what? 2 pi by t into t is equal to t by 2. What you get is, I won't write it here, I will just give you the result. 2 omega t, 2 into 2 pi by t, put t is equal to t by 2, t cancel, 2 cancel. What you get is sine 2 pi minus lower limit, put t is equal to 0, 0. Divided by whole thing is divided by 2 omega, that is of no use. Sine 2 pi is equal to what? Sine of 0, 0, sine of 1 pi, 0, sine of 2 pi, 0, sine of 3 pi, 0. Sine of 2 pi is 0, this is already 0, so the total result is 0. What you get is Im square by 2 into t by 2 is equal to I RMS square t by 2. This t by 2 and t by 2 is cancelled. What you get is I RMS is equal to Im. This is square, that is why. So RMS value is what? I max by root 2. Root 2, 1 by root 2, try, this value comes out to be what? Yes, 0.707, say 0.7 root 2. 1 minute to complete. Refer to the numericals, page 4 by 105. Page 4 by 105. Page 4 by 105. Numerical number 8. One minute to go through the question. Question is, the peak value of AC of a frequency 50 Hertz is 14.14 amperes. Peak value means what? Maximum value. Full stop. Find the RMS value of current. That is first part. Second part, how much time will the current take in reaching from 0 to maximum value? Try. Given is alternating current, sine wave. Maximum value is how much? Yes, 14.14 amperes. First part. I max is given 14.14 ampere. Frequency, yes, 50 Hertz. Find A part, I RMS. What was the conclusion of the previous question? Derivation, I max by root 2. 14.14, root 2 is equal to 1.414. Yes, comes out to what? 10. First part is 10. Now try the next part. The next part is how much time it takes for the current to reach from 0 to maximum value. That means this time. This is what of the total? Total time is capital T. This time is T by 4. So you have to find out T by 4. Frequency is given 50 Hertz. What is the time period equal to? 1 by frequency, 1 by 50 is equal to 0.02 seconds. Total time is 0.02 divided by 4, 0.005 seconds. Draw a diagram. Question is numerical number 10. Yes. The electric current in a circuit is given by I is equal to I naught T by tau. Let me write this as I is equal to I naught. T is a time, it is variable, by tau is some constant. We can write this as capital T for convenience. This is how time varies. This is constant. Calculate the RMS current for the period T is equal to 0 to T is equal to capital T. Yes. I is a constant or variable? I varies with time. What type of graph? Yes, I T graph is a straight line. I is proportional to T, straight line passing through origin. Up to what time? Capital T. You have to find out what? RMS value is that current when flowing in the circuit causes what? Same heat. That is why if you remember this I RMS equal to I max by root 2, it won't work because it is for a sine wave. Here the examiner has come out with on funda. Any number of questions, I is equal to I naught by t, t square plus 3t, number of questions. So you need to carry the concept. What is same? RMS is defined on the basis of what? Same heat. So if this wave, if this current flows, heat produced will be I square R dt under root. If this current flows, then heat produced is I RMS square R into T. Use it and come out with the answer. IEEE question. Number of times in number of competitions, same question. R is cancelled. So I can write it like this. I RMS square into T is equal to integration of I square dt, limits 0 to T. Try. I is equal to what? Given in the question. How I varies time will be given by the examiner. Yes, I is equal to what? I naught by T into T square dt. Limits we will put at the end. It is I naught square by T square small t square dt is equal to I naught square by T square. When you say integration of T square, yes, integration of x is power n. X is power n plus 1 divided by n plus 1. So it is T cube by 3, limits 0 to capital T. Try. I RMS square into T is equal to I naught square by T square into upper limit T cube by 3, lower limit 0 cube by 3. So what you get is T cube by 3 minus 0 cube by 3, what you get is I naught square into T by 3. This is I RMS square into T. T is cancelled. I RMS is equal to I naught by root 3. Mark this question as important. Why? Why an important question? Because either you get a standard format sine wave, cos wave, for which the answer is known to everyone. So that falls in the category level 1 and level 2. The examiner will give you I, how I changes with time. It may be a quadratic, I is equal to t square plus 3t plus 5. It can be anything. Then you need to take the first step, that what is same? Heat. Same heat flowing. Then you will have to use the concept and come out with the complete derivation and the result. That is why it falls in the category level 3. It's a level 3 question. We take minimum 3 to 4 minutes time. One more question. Numerical number 9. Numerical number 9. These are termed as sine wave questions or wave questions. The effective value of current in a 50 cycle AC circuit is 5 ampere. Effective means RMS value. What is the value of current 1 by 300 second after it is 0? A wave I. You have to find out I when. Yes, T is equal to 1 by 300 second. Is there any relationship between I and T? Yes. How the two are related? Yes. I is equal to I max sine omega t. This is what you need to find out. I when t is given how much? 1 by 300. I max, yes, maximum value of current is equal to root 2 times RMS value. What is RMS value here? 5. So what is maximum value equal to? 5 root 2 sine bracket omega is 2 pi f t. 5 root 2 sine 2 pi f is how much? Frequency given 50 hertz. Time is how much? 1 by 300. 5 root 2 sine, yes, 2 into 50, 100. This is 300. 100 by 300, 1 by 3, pi by 3. Pi by 3 is in degrees, yes. Sine pi by 3 means sine 60 degree. Sine 60 is what? Root by 2. Solve and come out with the answer, please. Is equal to what? I will write the answer. You confirm it. Calculate and confirm. It is 6.12 amperes.